Welcome to The Explainer. Today, we're diving into a question that sounds simple, but is actually incredibly complex. Why is AI so forgetful? We're going to break down how developers are giving AI a real memory and what that means for all of us.
So here's our game plan. We're going to trace the whole evolution of AI memory, starting with the basic problem and moving all the way to the cutting-edge future. We'll see how AI is going from a simple chatbot to a powerful agent that can actually remember, reason, and act.
All right, let's kick things off with a super frustrating experience that I bet almost every single one of you has had with AI.
You know that feeling, right? When you're explaining the same thing to an AI over and over again, you feel like you're stuck in a loop, giving it the same info for the fifth time. Well, you're not going crazy. There is a fundamental reason for that, and it's the core problem we have to solve to make AI genuinely useful. So here's the thing. Most large language models are what's called stateless. The goldfish analogy here is perfect. Every single interaction is brand new to them. They have zero memory of what you just said 5 seconds ago, which is why they keep asking for your passport info. The goal, of course, is to create stateful AI, a real assistant that remembers you, your preferences, and learns from your conversations.
So to make AI actually work for us, we have to solve this amnesia. And the very first step? It's giving it a persistent memory.
This idea, persistent memory, is basically the digital version of our own long-term recall. It's the secret ingredient that separates a dumb tool from a true assistant, one that actually learns who you are and what you care about over time.
And just like our own brains, this memory isn't just one big blob. It's really broken down into two main types. You've got your short-term memory, which is a lot like the RAM in your computer. Super fast, but it's temporary, just for the task at hand. And then you have long-term memory. That's the hard drive, where it stores tons of information that lasts across all your conversations.
And if we zoom in even closer, that long-term memory comes in 3 distinct flavors. First, there's episodic memory, which is like a personal diary of your past interactions. Then you've got procedural memory, which is all the how-to knowledge for doing complex stuff. And finally, there's semantic memory, and that's just the AI's huge library of facts about the world.
But, having a massive memory is pretty useless if the AI can't find the right information when it needs it. And that brings us to this really cool technique called RAG. I love this analogy of the open book exam because it just perfectly captures what RAG does. See, instead of trying to force an AI to memorize the entire internet, which is impossible, RAG gives it the ability to go look up the facts from a reliable source before it gives you an answer. It's just so much smarter.
And that open book at the heart of the whole system is a special kind of library called a vector database. It's incredibly clever. It doesn't store words, it stores their meaning as numbers. This lets it understand that, say, Eiffel Tower and famous Paris landmark are conceptually related, so it files them right next to each other for easy access.
The process itself is actually pretty simple. First, the system retrieves the relevant facts from its database. Then, it augments your original question with those facts, making it way more context-rich. And finally, the AI generates an answer based on this new, fact-checked prompt. This is exactly how we get AI answers that are grounded in reality, not just hallucinations.
And here's a little peek under the hood at the actual logic. The agent gets a result from a tool, could be a calculator, could be a database, and then it uses that hard information to formulate its final, accurate answer. It's a really clear loop. Retrieve the facts, then generate the response.
So our AI can remember things and it can look stuff up. Awesome. But what happens when it needs to actually act in the world? When it needs to use different tools, databases, and APIs to really get a job done? Well, this is where the Model Context Protocol, or MCP, comes into play. It's been called the USB-C for AI, and honestly, that is a perfect description of its goal: to be the one universal connector that lets any AI plug into any tool.
MCP basically acts as a universal translator. It's a single, open standard that tells an AI agent what tools are out there, what they can do, and exactly how to use them. This completely gets rid of the need for custom, one-off integrations for every single little tool. And here's why MCP is such a huge deal. It's an open standard. Think about that for a second. You have fierce rivals like Anthropic, OpenAI, and Google DeepMind all agreeing to use the same plug. That kind of cooperation is pretty rare, and it tells you that this is quickly becoming the essential language for how AIs interact with the digital world. So why does all this matter to you? Well, MCP is the key that unlocks truly agentic systems. It's what allows a single AI to perform complex, multi-step tasks in the real world, orchestrating a whole bunch of different tools to achieve a goal.
Okay, so we've given our AI a memory. We've given it a way to look things up, and we've even given it a voice to talk to tools. But there's one final, absolutely massive leap we still need to take.
See, today's systems have what you might call a shallow memory. They remember what they did. The future, which some are calling contextual memory intelligence, is all about creating a deep memory. An AI that remembers why it made a certain choice, including all the other paths it considered and decided against.
CMI is really a whole new vision for AI systems. Systems that don't just do tasks, but actually reflect on them. It reframes memory as this living, adaptive infrastructure that allows an AI to learn from the entire contextual journey that led to a result, not just the final result itself.
This shift in thinking is captured perfectly in this quote. The idea behind CMI is that knowledge isn't some static thing you just store away. It's a dynamic process that evolves as the AI acts and learns from what it's doing.
And ultimately, that's what this is all about. It is the difference between an AI that can follow a recipe to the letter and an AI that can actually invent its own. This is the path toward AI that's not just more effective, but also more auditable, more traceable, and frankly, more aligned with our own complex way of thinking.
And that brings us to our final provocative thought. As we build AI with this truly deep, reflective memory, one that understands the full story behind our choices, what incredible new possibilities and what profound new responsibilities will start to emerge.